Hello students, let's understand today what is the deterministic channel. So the channel described by a channel matrix. So you know the channel matrix is probability output given input. That means it's the matrix of probabilities output given input. So in this channel matrix, if there is only one and one non-zero element in each row, then that channel is called deterministic channel. So here we will see the one example for this channel matrix. So let us consider the input to the channel is a symbol capital X. It is represented by a symbol capital X with the inputs x1 to x6, and the output of the channel is a alphabet or symbol Y with the outputs y1, y2, y3. That means this alphabet or this set contains these three elements and this set contains these six elements. So the what is the channel matrix? Channel matrix is the probability output given input. So in this channel matrix, that is probability y given x, there is only one non-zero element in each row. So there is only one non-zero element in each row. So you know the channel, the channel matrix representation. So here we represent input, here output. So there is only one non-zero element in each row. Okay, so you know that the channel matrix rows elements addition should be 1. So if there is only one non-zero element, that means if there is only one non-zero element, then its probability should be 1, because addition of this term plus this term plus this term should be equal to 1. Here also addition of this should be 1. That's why the probability is 1 in each case. So there is one non-zero element in each row, and that non-zero element should be 1, because the addition of all the element, that is the condition for the channel matrix, that addition of all elements of one row is equal to 0. Here this addition should be 1, these three elements addition should be 1, this three elements addition should be 1. So this is the channel matrix. Now from if you observe this channel matrix, here only you can write that entropy h y given x is equal to 0, because in entropy y given x, the probabilities are all these probabilities will be there. You know the formula for the entropy, that is p log 1 by p. So here the probabilities are 1 0 1 0 0. So the probabilities are either 1 or 0. So here h, that is entropy y given x, is equal to 0. So that is important point. Now then we obtain the joint matrix. You know already we have seen that the joint matrix can be obtained from the channel matrix, from this matrix, by multiplying each row with this with the corresponding input probabilities. So this row is multiplied with px1, this with px2, this with px3, px4, px5, px6. So same is written here. Px1, px2, 0 is multiplied by px1, that is 0. So px1, px2, px3, px4, px5, px6. Now we are not going to find the entropies. We will observe what could be the entropies and write down the equations. So in a pxy, you can see that all the probabilities are either px1, px2, px3, px4, px5, px6, and in the input symbol x1 to x6, the probabilities are px1, px2, px3, px4, px5, px6. So hx, which includes the probability px1, px2, px3, px4, px5, px6. Same way, hxy will include the probabilities px1, px2, px3, px4, px5, px6. We are not going to apply the formulas, that is px1 divided px1 log 2 1 by px1, px2 plus px2 log 2 1 by px2 plus px3 log 2 1 by px3. Likewise, by observing the probabilities, we can say that hxy is equal to hxy. If you compute hxy, it includes all these probabilities, and if you compute hx, it will also include all these probabilities. So hx comma y is equal to hx. Okay, And we have already observed that hy given x is equal to 0, because here in this channel matrix the probabilities are either 1 or 0, so its entropy is equal to 0. Now let us find ixy, that is mutual information. So ixy is equal to hy minus hy given x. Now hy given x is equal to 0, so ixy is equal to hy. There is another formula for ixy, because you might get confused, or you might have the question whether this result will be applicable to all the formulas. So ixy, second formula is hx minus hxy. So hx minus hxy can be written as hx comma y minus hy. So you know hx comma y is hx for this case. So hx minus hx plus hy. So again hy. Third formula for ixy is equal to hx plus hy minus hxy. So hx plus hy, hxy is equal to hx minus hx. So again hy. So in all the three formulas we are getting ixy is equal to hy. We have not computed this one because it will become again lengthy process, that's why, but we have shown that in every case you are getting ixy is equal to hy. So this is mutual information, ixy is equal to hy. Okay, what is the capacity? Capacity is max of ixy, max of hy in this case, and you know that entropy is maximum value. This is entropy of y, so its maximum value is log 2 of 3. Why 3 here? We write log 2 of m, that is m is size of this y. So what is the size of y? Size of y is 3. 1 2 3, number of elements in y is 3, so the capacity is equal to log 2 of 3. So this is all for the deterministic channel. One thing I want to mention you here, that what is this, what does this mean? So hy given x is equal to 0. That means it's somewhat difficult to understand, but I try my level best to let you or make you understand. So hy given x is equal to 0. That means information is equal to 0, because entropy is information, so information is equal to 0, and you get the information equal to 0 if the probability is highest, or there is probability is equal to 0. That means it has no probability, or it has highest probability. That means you know the know everything, I can say probability is highest. So hy given x is equal to 0. That means information is equal to 0, means probability is equal to highest. That again mean that input symbols are sufficient to say everything about output symbols. That means input symbols x1 to x6 can tell the what could be the output with 100% probability. So this is the meaning of hy given x is equal to 0. As we have seen that if the probability is highest or probability is 0, then we don't get any information. So in this case information is 0, that means probability is highest. That means x defines y very well. X defines y very well. So this is somewhat tricky to understand, or we can say somewhat difficult to recognize also, how the physical or how we put it in wordings. So input symbols xi will be sufficient to determine output symbols yj with probability 1. So its meaning is input symbol xi will be sufficient to determine output symbols yj with probability 1. So that is it for this video. So I observed that many are liking these videos, also sharing these videos, so but missing the subscription part. It may happen that we forget to subscribe to the channel. So I once again remind you to subscribe to the channel for more such videos. Thank you very much.